In this lesson, we are going to introduce a little bit of the idea of a polar form of complex numbers specifically. We'll also kind of refer to it as a trig form. So remember that a complex number had an a plus bi kind of a look to it, where a was the real number, the bi was the non-real / imaginary piece of this, and together they were called a complex number. So we are going to graph them. And so I have three different colors to show it a little bit easier on a graph. The way that you graph it is actually kind of like a vector. So a complex number gets really treated like a vector. So it's its own kind of scale grid. That's why you've never graphed anything like this. So when you've done quadratic formula and these were solutions and they didn't show up on the graph, it's because there's a whole different type of graphing. And your x-axis becomes your real axis and your y-axis becomes your non-real axis. So if you're going to graph 3 plus 2i, we're really going to treat it like a vector. So let me pull a graph into this. And so if we're going to graph 3 plus 2i, we are going to, 3 is our real, and the 2i is our non-real. So that is our coordinate, and that represents 3 plus 2i. So it's kind of hard to see with the green. All right. And then if we do the blue, -3 minus 2i, same exact idea. So we have a -3, -2i. So that one would look like that. And then if you are graphing the sum, I'm going to do a long way real quick, and then I know I could add these together, but I want to show you that it is very, very much like vectors, because if you were to graph 6 minus 2i, so you'd have 6, 1, 2, 3, 4, 5, 6 minus 2i, you would have this vector. And then if you had a -4, -3, 1, 2, 3, 4, 1, 2, 3, so let me get rid of these original ones. Remember that if you add vectors together, it's tip to tail. So this left 4, down 3, we could take from here and go 1, 2, 3, 4, 1, 2, 3. And that would be kind of a tip to tail on those things. And your resultant vector is this. So that would be the sum of them. Well, that is a 2, 2, and then we're going down 1, 2, 3, 4, 5. So 2 plus 5i is what that vector would look like. So that's the visual look to it. And obviously if I do the math, I should get this exact same thing. So 6 plus the -4 is 2, -2 and the -3 makes 5i. So I'd be graphing 2i by going right to, minus 5i, right to down 5i. So they both work. Most likely I'm going to add them together and then graph it, but I wanted to show you that if you take that vector and add that vector to it, you're going tip to tail, or you could have done this vector and then you could have went right 6, down 2, and you would have gotten the exact same location. So there's definitely some vector combination, some vector feel going on to this. The math is all kind of the same, but that is what a complex number looks like on a grid. It's a totally different scale. You got reals for your x and x-axis and non-reals for your y-axis. All right, so that is complex numbers graph.